Hello, this is Mr. Wynn, and today's lesson is analyzing graphs of polynomial functions. So, to graph polynomials, the best method would be use a calculator, but if you had to do it by hand, you should plug in x values to find the y's. Also, you can use decimals like this. So, for example 1, they plugged in negative 2.5 for x, they got y was negative 41. They plugged in negative 2 for x, they got y was negative 16, negative 1.5 for x, you get that. Do it for all the points, and you get a bunch more. So they put a graph on the right side, and that's all we need there. In that same example, notice there were two zeros or roots or x-intercepts. You see in the picture. Remember, you can find the zeros from a table like before using the location principle. What that says is if the value of f of x changes, meaning if y changes, signs, meaning from positive to negative or negative positive, there is a root there. So that's called the location principle. So we're going to locate the zeros of this function. Well, there's a table. We're going to figure out where the f of x or the y changes signs. So it's negative 29, negative 7, positive 1. So right there, between negative 1 and 0 for x, there's a root, or 0. And positive 1, negative 1. So right there's another root. Then negative 1 to positive 1, there's another root. There's at least 3 roots here. Right, and they did graph this, so here's what it looks like. There's 3. 1, 2, 3. Alright, for cubic functions or anything above degree 2, there's still maximums and minimums, but we call them relative maximum and relative minimum. So they're no longer the max of the whole function because this one goes up forever and it goes down forever. But for their general location, there's something either above them or below them. So it's like a piece of a parabola, a piece of a u there. So here there's one relative minimum and one relative maximum. These are also called extrema. So minimums and maximums are always called extrema. And also where the minimums and maximums are, those are called turning points. Turning points just mean when the graph turns. So for example, this right here is going down, it's decreasing, and then it turns, it starts going up. So that's a turning point right here. That's a turning point. Went from going down to going up. Then it's going up right there, then it goes down. So that's a turning point. It goes up, increases, then it decreases. So the number of minimums and maximums match the number of turning points. And if you have degree n, there's at most n minus 1 turning points. So write this down. The degree of a polynomial can tell you a lot of information. The number of roots there are, both real and imaginary, together they have to be the same as the degree. The number of extrema, minimums and maximums, which is the same as the number of turning points, that's always going to degree minus 1. And then the end behavior. So even degrees go the same way, odd degrees go opposite ways. So here's a quick example. If I have y equals x squared, I know it looks like this. So on the left side, it goes up to positive infinity. On the right side, it goes up to positive infinity as well. Right, so they both go up to positive infinity. If I have y equals x to the first power, that's odd degree, it looks like this. On the left side, it goes down to negative infinity. That's what y does. On the right side, it goes up to positive infinity. So they went opposite ways. Right. For example 3, what's the smallest possible degree for this graph? Also state the number of extrema, minimums, maximums, and turn points. Well, here's this counting. Count however you like. I'm going to count the minimum points first. So here's a relative minimum, here's a relative minimum, here's a relative minimum. So there's 3 minimums. All of them are, the first 2 are relative. This one is actually the absolute minimum because there's nothing lower than that. For maximums, there's 1 maximum, 2 maximum, that's it, and they're both relative maximums. So there's 3 minimums, 2 maximums, that means there's a total of 5 extrema. Well, there's 5 extrema or 5 total maximum minimums, that's also 5 turning points. And remember, the degree is 1 more than that. So if there's 5 extrema, there's degree is 6. Or you can say there's 5 turn points, the degree is 6. Here's your practice problem. Figure out what the smallest possible degree is for this graph. Hint, use or count the minimums and maximums. All right, and the answer should be 5. If you knew that, you should be fine in class. Thanks for watching. See you in class.